Hello students, welcome back to my channel. Today we are going to learn some applications of previous video and some definitions. So if you want to check the previous videos, go to the description box. Link will be given over there. So without any further delay, let's get started. I have chosen some of the questions for you like number 1. The collection of novels written by Munshi Premchand. So the novels by Munshi Premchand. Is it a set? Yes, this is a set, as we can figure out all the novels. Okay. Novels by Munshi Premchand are obviously very easy to find out. So this is a set. So this is well defined. Then number 2. The collection of 10 most talented writers in India. Do you think this is a set? No, this is not a set, because the word talent is not well defined. Means everybody will have different taste of talents. The next question is, you have to put either this sign or this sign, that means belongs to or doesn't belong to, in the blank. Suppose A equals to 1, 2, 3, 4, 5, 6. Therefore 8-A. What will be here in the blank? Belongs to or doesn't belong to. You can see from this set, 8 is not an element of the set A. That means 8 doesn't belongs to A. Similarly, for 1, 2, 3, 4, 5, 6, any one of that, like 5, what it will be here in the blank? It will be belongs to A. Then find sets in roster form. That means set builder form is given, you have to find it in roster form. Suppose A equals to x such that x is a prime number which is a divisor of 60. That means first thing is what prime numbers are factors of 60. Factors of 60, that means 60 equals to 2 into 2 into 3 into 5. So what are the prime numbers? 2, 3 and 5. That means A will be in roster form 2, 3, 5. Coming to next type, that is let A equals to 5, 25, 125, 625. Look, A is given in roster form. So you have to first look at the numbers and find the relation. You can see first is 5, second is 5 square, third is 5 cube, and fourth is 625. That means it's 5 to the power 4. So in all 4 elements you can see 5 is common. That means we can write A as 5 to the power 1, 5 to the power 2, 5 to the power 3 and 5 to the power 4. This is the roster form. So in set builder form we can write like this: A equals to 5 to the power x such that x belongs to natural number set and x less than 5. Natural number set and x less than 5 means it will be 1, 2, 3, 4. So we have actually described the condition for this x, that is the power of 5. Okay. Now we will get in some important concept, that is empty set, finite or infinite set, equal sets, subsets, then singleton set, then intervals, then power set, and last universal set. So starting with empty set. What is the definition of empty set? Empty set, the name itself is telling that the set will be empty. That means a set which does not contain any element is called empty set or null set or the void set. Okay, it's the empty set's symbol is phi, or simply somebody can write down like this, just 2 second brackets and the middle portion will be empty. So this also can be represented for phi, means null set or empty set. Okay. For example, b equals to x such that x square equals to 4, x is odd. X is the element, x square, condition is x square equals to 4 and x must be odd. Then obviously b is phi. Why empty? Because x square equals to 4, obviously x will not be odd. That means x is odd doesn't satisfy that equation x square equals to 4. So we are getting b equals to the empty set phi. Next is finite or infinite set. Finite or infinite set, the name is telling that a set which contains finite elements will be called as finite set, and a set which contains infinite elements will be called as infinite set. For example, A be the set of students in your class. Obviously A is then finite, and B the set of radii in a circle. Therefore obviously B is infinite. Why infinite? because number of radii in a circle is infinite, as number of points on the boundary are infinite. Now, equal sets. Two sets A and B are equal if they have same elements. That means two sets will be called as equal sets if they have all elements same. Next one is subsets, and this is very important concept. Subsets. A set A is said to be, this A is the set. A set A is said to be a subset of another set B if all elements of A is also an element of B. That is, we will write it as A subset B. In other words, we can say that A is a subset of B if small a, suppose small a belongs to capital, that means small a is any element of A, it implies that small a obviously belongs to B also. Then we can write the definition of subset in this way also. Now, if A is not a subset, then we write A is not a subset of B. Now, suppose A subset of B and B subset of A simultaneously. That means A equals to B. So we can write it as A subset B and B subset of A implies that and implied by A equals to B. This implies that and implied by can be written as if and only if. IFF, if and only if. It will be read as if and only if, but will be written as IFF. Okay. Now, phi is subset of all sets. Any set you take, phi always will be subset of it. Now, if A subset of B, then we call A is proper subset and B is superset. B is superset. In this condition, A is proper subset and B is superset. Okay. Now there are two types of symbols of subsets. This one is proper subset and this one is subset. Now just to get the clear idea out of it, suppose A equals to 1, 2, 3 and B equals to 1, 2, 3, 4. Then you can see that all elements of A are elements of B also. That means which is the bigger set? B is the bigger set. So this open portion will be towards B. That means A subset of B. A is the smaller set here. Okay. A is subset of B. As number of elements in A and number of elements in B are not same, and B is the bigger one, that's why we are using proper subset sign. But suppose A and A, we are taking two sets A and A. So we can write, somebody can tell that we can write A equals to A. Obviously we can write A equals to A, but there is another way we can write A is obviously subset of A. So these together we can write A is a subset of A. So this actually consisting of two different conditions. It can be equal or it can be proper subset. So you can write anything. Next one is singleton set. Singleton set, it means singleton, it means only one element. A set which is having only one element is called a singleton set. Like 1, like 2, like 3, like A, like I. So all are having only one element. Now intervals. This particular thing you will be using very frequently in upcoming syllabus. So intervals, that is subsets of the real number set R. Now you all know about the real number line, right? What was it? It was like this. This is 0. This side will be positive. This side will be negative. I am just writing some of the countings. 1, 2, 3, 4. I have not measured it by scale. So maybe these are not properly equal. Just forget it. This is -1, -2, -3, -4 like this and so on. So this side so on, this side up to plus infinity, this side up to minus infinity. Okay. Now, there are 3 types of intervals. Number 1. Suppose I am writing 1, 3 inside first bracket. This set contains all numbers between 1 to 3, but not 1, not 3. After 1, any element. Before 3, any element, but not 1 and not 3. And this is called open interval. Then number 2. Suppose I am writing -1, 2 in third brackets. It means the set contains all numbers from -1 to 2, including -1 and 2. Means all from -1 to 2. Okay, and this is called closed interval. There are another 2 types of intervals like A, B and A, B. You can see for the first interval I have used open for A and closed for B, and in the second interval I have used closed for A and open for B, it means this set contains all elements after A up to B. This set contains all elements from A before B. Okay, that means this set doesn't contain A and this set doesn't contain B, as A here is in open position and B in here is in open position. Okay, so these two types of intervals are called semi-closed or semi-open. Anything you can tell, semi-open or semi-closed intervals. Okay, next is power set. Let A equals to 1, 2. I am taking very small set so that you can get the idea very easily. Therefore, subsets of A. First of all, subsets of A, when we are thinking, we will always write phi first, because what I told that phi is a subset of every set. So phi, then singleton sets, singleton 1, singleton 2. Then what is left? With two elements, 1 and 1 comma 2. We can write this or we can write directly A, doesn't matter. So we have got all these four sets, all these four subsets precisely. So the power set of A is denoted by P of A is equals to capital P of capital A. Power set of A is equals to phi, then 1, then singleton 2, then singleton 1 comma 2 or A. Now look, I have used 2 times second brackets. Now you must be thinking that why we are using it, because power set is also a set. When we are writing power set, these are not different sets, rather these are working as elements of the set, that is power set, this set. Okay, and the last one is universal set. Universal set means in different cases universal set will be different. Like for system of numbers, we are interested in natural number and its subsets, such that set of prime numbers. Suppose we are finding set of prime numbers or set of even numbers, then obviously the basic set is natural number set. So natural number set is the universal set. In other words, or in short, you can say the basic set always will be universal set. Okay, and universal set's symbol is capital U. It's not union sign, it's capital U, the alphabet U. Okay, so this is all about today's session. I hope you all have got a clear idea about all the topics that is discussed today. We will meet in the next session. Till then, you do your homework, that is exercise 1.1, 1.2 and 1.3. All questions from these 3 exercises. These 3 exercises will be your homework. So, thank you everybody.